Alright, so in lesson 1 we're going to be learning about similar triangles. And we're mostly going to be learning three things. And the first thing is how to write that two triangles are similar using math notation. And the second thing we're going to learn is actually split into two parts, two properties. The interior angle property. If you have two similar triangles, there's something that's special about their interior angles. And also the proportionate side property of similar triangles. Similar triangles, what are they? These are triangles that have the exact same shape but aren't necessarily the same size. You can see that there are four triangles there. There are four different sizes, but they're all the exact same shape. Now, in order to prove or to show that two triangles are similar, you have to prove that the triangles have one of these two properties. First of all, you could prove that all of the interior angles, that is the corresponding angles between the two triangles, they have to be equal to each other. Or we can prove that the ratios of the corresponding sides are equal to each other. And we'll go through both of these properties with examples, and that will help them make more sense. Okay, so the first property is that all interior angles, or corresponding angles, must be equal if the two triangles are similar. Okay, so given that triangle ABC is similar to triangle XYZ, then, or in other words, what do we know about these two triangles? Well, the first thing that we know is that angle A must equal angle X. Okay, and you can see it's already been marked here, right? Angle A has been marked with this little square, angle X has been marked with this little square right here. That's just notation showing that they're equal to each other. And in the question, we were told that these two triangles are similar, so we know that those angles are equal to each other. Okay, we know two other pairs of angles too, right? We also know that angle B is going to be equal to angle Y. And thirdly, we also know that angle C is equal to angle Z. Since we have these three pairs of angles from the two triangles, so in other words, all of the interior angles, the corresponding angles, are equal to each other, we know that these two triangles are similar. So how can we write that these two triangles are similar? Well, the first thing that we do is we just write down the first triangle in any order of the letters. We're going to stick with A, B, C just because it's nice. Our brains are used to that. So we know that triangle A, B, C is similar to, now it's not identical, right? You can see ABC is a little bit smaller, so we can't write an equal sign. So when we write that something is similar, we use a double squiggly line. It's like an equal sign that got squiggled, kind of. So triangle ABC is similar to triangle. Now the order of the second triangle is really important. Because angle A comes first here, we have to put the angle that matches angle A. Angle X is the same as angle A, so angle X has to come first. B comes second in this triangle. B is the same as Y, so Y has to come second in this triangle. Since C comes third, Z must come third in this triangle. Now this is one of several different ways we could write the similarity statement, and I'll show you one other one. If we were to pick a different order here, instead of writing ABC, let's say we wrote triangle CAB. Okay, so we're just thinking of this triangle as triangle CAB. That is not similar to triangle XYZ. Okay, that would be writing it incorrectly. Since C comes first, we must write the letter that corresponds with the angle that's the same as C. So we have to write triangle Z. A is the same as X, so Z, X, and then B is the same as Y, ZXY. Okay, so as long as this angle is the same as this angle is the same as that angle, and this angle is the same as that angle, you're doing it correctly. Just double check and always make sure you're doing that correctly. In the second example, we're asked to prove whether these two triangles are similar or not. And if they are similar, write the similarity statement. Excuse me. Well, the first thing that I notice when I look at these two triangles is that angle N and angle S are both the same, right? They're both 65 degrees. So we already have these two angles as being the same. However, angle M doesn't have an angle that's the same over here, and angle T doesn't have an angle that's the same over here. Now perhaps T corresponds with O and M corresponds with U, but we're not sure yet. We're going to have to do a little bit of math to figure out if that's the case. Okay, hopefully you remember that the sum of the interior angles of any triangle is 180 degrees, so let's figure out angle O first. So angle O is going to be equal to 180 minus these two angles. So minus the 65 degrees and also minus the 30 degrees. And 180 minus 65 minus 30 is actually 85 degrees. And you can check that on your calculator. We're also going to check angle U right here. So angle U is going to be equal to 180 minus the 85 and also minus the 65. And when you do the math, it turns out angle U is also 30 degrees. So we know that angle U is equal to angle M. We know that angle S is equal to angle N. Oops. And we know that angle T is exactly the same as angle O. Therefore, we know that this triangle right here must be similar to this triangle right here because all three of the interior angles are identical. Now, all we have to do, so that's us, we proved it. If they are similar, write the similarity statement, and that's what we're going to do now. I'm just going to write down the letters from the first triangle, M and O, because that's the way our brain works probably. So triangle M and O is similar to triangle. Now remember, we have to line up the M with the angle that's the same as the M. M is the same as U. So triangle U, S, T. M is the same as U, N is the same as S, O is the same as T. We know we're doing it correctly. Okay, so in our next example, we're going to look at the second property, which is that the ratios of the corresponding sides must be equal. Now for this property, we're not really looking at the angles at all. We're just looking at the side lengths of the two triangles. Now, at first glance, these two triangles don't exactly look similar. They could be, but it's hard to tell. But if they are similar, then the ratios of their corresponding sides must all be the same. So we're going to look at this side length here first. Side length AB. Okay, so that's the shortest side, and the shortest side on this one is this one right here. So the length of AB, and side AB is just if you were to draw the line straight from A to B, so we're talking about this side. The length of AB, which is 6, so AB is 6. The length of AB compared to the length of XY, length of AB compared to the length of XY, and the length of XY is 3. So 6 divided by 3 is 2. Now let's do that for all of the other sides. So next, let's look at the middle length. There's the middle length from this triangle and the middle length from this triangle. So that means that the length of BC compared or divided by the length of YZ. Those are the middle lengths. And we can see that the length of BC is 14 and the length of YZ is 7, and 14 divided by 7 is also 2. Notice that these two 2's are exactly the same. Now these two triangles will be similar as long as we can show that the third pair of side lengths also has the same ratio. So if we were to compare side length CA to side length ZX, these are the two longest ones, we would find that CA is 24 compared to ZX, which is 12, and 24 divided by 12 is 2. Now these 2's all mean, really, that this triangle's side lengths is twice as long as this triangle's side lengths. And you can see that, right? 12 times 2 is 24. 7 times 2 is 14. 3 times 2 is 6. This triangle is twice as big as this triangle, in other words, in terms of a scale. So you can think of it that way. So now we're asked to prove that the following two triangles are similar or are not similar. If they are similar, we have to write the similarity statement. Okay, so the first thing that we need to do is kind of match up the sides. Notice that there aren't any angles here to deal with, so we're looking at the side lengths. And remember, if the corresponding ratios, if the ratios of the sides are all equal to the same thing, then the triangles must be similar. So I'm going to start with the shortest and work my way to the biggest. So here are the two shortest side lengths. So let's compare side length, here. Actually, it's a lot easier if you start with a bigger triangle. So one trick is start with the bigger triangle, write down that one compared to this one. So let's write FG, the length of FG compared to the length of SU. Notice with FG, I started at the angle that looks like a 90-degree angle and came over to this sharper one. So I'm going to do the same thing, S, 90 degree towards U, just to be consistent. Okay, so the length of FG is 12, and the length of SU is 4. And 12 divided by 4 is 3. Let's do it with the other sides. We'll grab a different color now. Let's compare the length of EF to the length of TS. So the length of EF compared to the length of TS. EF is 25.5 and TS is 8.5. And I'm going to not be able to do this one in my head, so we'll pull out the calculator, and we find that 25.5 divided by 8.5 is also 3. And for the third side, we'll grab a third color. So the length of EG compared to the length of TU. So EG is 33 and TU is 11. Should be able to do that in your head. Now since all three of these are the same, we know that these two triangles are similar. And now it's just up to us to write the similarity statement. Okay, so for our similarity statement, let's pick triangle EFG first. So triangle EFG is similar to triangle. Now we have to make sure that we line up the angles from the first triangle with the angles from the second triangle. So angle E, which is the one that's on the long skinny end, that should be the same as T. F is in the middle we picked. It's the 90-degree looking angle, and that lines up with S, so S will come next. And G is last. There's only one angle left. Triangle EFG is similar to triangle TSU. So in summary, similar triangles are triangles that have the exact same shape, but they aren't necessarily the same size. To prove that two triangles are similar, you have to prove that the triangles have one of these two properties. You either have to prove that all of the interior angles are equal, or that the ratios of the corresponding sides are all equal. All of the ratios are equal. And lastly, when you're writing similarity statements, make sure the second set of the three letters correspond with the matching letters from the first triangle.